Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we'll be looking at our times table, and we'll be filling it out diagonally using some of the things that are inside and secret things inside the times table to help us do so. Let's start. Let's start with something familiar. Let's start with the ones. Now we know that ones are special in multiplication because they're the identity number. Any number times 1 will be itself. So 1 times 1 is just 1, 1. It's 1, right? 1 times 2 is just 2. 1 times 3, 1, 3 is 3. 1 times 4, 1, 4 is 4. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9, and 1 times 10 is 10. We could think about it the other way, though. Now watch what happens here. 1, 1 was 1, but what if we think about 2 ones, or 1 times 2? It will still be 2, right? 3 ones, 1, 3, 3. 4 ones, 1, 4, 4. 5 ones, 1, 5 is 5. 6 ones, 1, 6 is 6. 7 ones, 1, 7 is 7. 8 ones, or 1, 8 is 8. 9 ones, or 1, 9 is 9. And lastly, 10 ones, or 1, 10 is 10. Now how does this work? Well, multiplication has a special property, and we'll be using that today to do this table. Multiplication is commutative. And what does that mean? What it means is that 1 times 3 is the same as 3 times 1. We end up in the same place, don't we? We did that. 1 times 3 is 3. 3 times 1 is 3. 1 times 3 is 3. 3 times 1 is 3. Always the same. So let's write that. 1 times 3 is the same as 3 times 1. Okay? So 1, 3 is the same as 3 ones, because 3 is equal to 3. Now let's keep using this, alright? So we can move the numbers around as we want and still end up with the same result because multiplication is commutative, right? And it's the same thing. Let's try our 2's now. Same as before. Let's put our 1's away. 2's. 2 times 2 is 4. 2 times 3 is double 3 is 6. 2 times 4 is 8. Double 4 is 8. 2 times 5, double 5 is 10. 2 times 6, double 6 is 12. 2 times 7, double 7 is 14. 2 times 8, double 8 is 16. 2 times 9, double 9 is 18. And 2 times 10 is double 10 is 20. We go the other way though. Look what happens. 3 times 2 here is the same as 2 times 3 here. So these two numbers are the same. Let me do that again. 3 times 2, what we want here, is the same as 2 times 3. We can write that over here. So 3 times 2 is the same thing as 2 times 3. We know that 2 times 3 is 6. Based on our rule over here, 2 times 3 is 6. We can say that 3 times 2 should be the same. So 3 times 2 gives us 6. What about 4 times 2? So 4 times 2 should be the same thing as 2 times 4, which is 8. following our rules, right? So 2 times 4 is 8. So 4 times 2 is also 8. Look at the pattern. What's going to happen with 5 times 2? That should be the same as 2 times 5, right? 2 times 5 is 10. So 5 times 2 is also 10. 6 times 2 for this one is the same as 2 times 6, 12. So this should be 12. 6 times 2 is 12. 7 times 2 should be the same as 2 times 7. Okay, so we have 14 here, seeing our pattern. What's the next one? Do you see it? 8 times 2 is the same as 2 times 8. So this one could be 16. 9 times 2 here should be the same as 2 times 9, which is 18 here. So 9 times 2 should also be 18. 10 times 2 should be the same as 2 times 10, 20. So we can say this will be 20. And we're using the commutative property again and again. So we've done our 2's now. Let's move to our 3's. You probably noticed that we've done many of them already. Some of our 3's are already done. Let's start with this special one here. 3 times 3 is 9. So 3 plus 3 plus 3 is 9. And you'll notice that there is no other, just the same. So 3 times 3 is 9. But we have to say 3 times 3 is the same thing as 3 times 3. That makes sense, doesn't it? But let's look at these other ones. 3 times 4 is 12. Okay, 9 and 3 more. 3 times 5 is 15, which is 12 and 3 more. 3 times 6 is 18, which is 15 and 3 more. 3 times 7 is 21, 18 and 3 more. 3 times 8 is 24, which comes from 21 and 3 more. 3 times 9 is the same as 24 and 3 more, which makes 27. 3 times 10 is the same as 27 and 3 more, which makes 30. Okay, let's use our rule that we've used before, right? If we want to know what 4 times 3 is, we should be looking at 3 times 4, right? Because our rule says that 4 times 3 should be the same as 3 times 4. Okay, 3 times 4 was 12, so we can say 4 times 3 is 12. Now why is that? 4 times 3, you could think about this as being 3 and 3 and 3 and 3, which makes 12. 3 times 4 we could think of as 4 and 4 and 4, which also makes 12. So they're the same, right? Let's keep going. 5 times 3 is the same as 3 times 5, which is 15. 6 times 3 is the same as 3 times 6, 18. 7 times 3 is the same as 3 times 7, 21. 8 times 3 is the same as 3 times 8, 24. Do you see how the numbers are lining up? There's symmetry to this, isn't there? So can you predict the next one? If I say 9 times 3, what should this number be? It should be the same as 3 times 9, which is 27. 10 times 3 is the same as 3 times 10, which is 30. Now we've done our 3's. All right, let's move to our 4's. We've done a big part of the table already, haven't we? In our 4's, you're probably noticing a pattern that the very first one we start with is the number itself. So 4 times 4. We'll talk about those later, but 4 times 4 is a special number. It's 16. And 4 times 4 makes 16. And again, 4 times 4 doesn't have a counterpart because it's just 4 times 4. But if we want to know 4 times 5, we have to think of 16 and 4 more, which gives us 20. 4 times 6, 20, and 4 more gives us 24. 4 times 7, 24 and 7 more gives us 24 and 4 more gives us 28. 4 times 8 is the same as 28 and 4 more, which gives us 32. 4 times 9 is the same as 32 and 4 more, gives us 36. 4 times 10, the same as 36 and 4 more, which gives us 40. Now we've done all the work for the 4's now, because remember, everything has a match. If we want to know 5 times 4 for this, we know that it will be the same as 4 times 5, which was 20. 6 times 4 is the same as 4 times 6, 24. 7 times 4 is the same as 4 times 7, which gave us 28. 8 times 4 is the same as 4 times 8, which is 32. 9 times 4 is the same as 4 times 9, which was 36. 10 times 4 is the same as 4 times 10, which is 40. Look again at the symmetry. 20, 20, 24, 24, 28, 28, 32, 32, 36, 36, 40, and 40. All right, we're getting down to one corner of our times tables, aren't we? Let's put the 4's away. And we'll bring up our 5's. And you know we have to start with that special one at the beginning, right? The first one's going to be 5 times 5. And as we said before, the only one that equals 5 times 5 will be 5 times 5. 5 times 5 is 25. Special number again. Let's go on to the next one. 5 times 6 is 25 and 5 more, which is 30. 5 times 7 is the same as 30 and 5 more, which is 35. 5 times 8 is the same as 35 and 5 more, which makes 40. 5 times 9 is the same as 40 and 5 more, which gives us 45. And lastly, 5 times 10 is the same as 45 and 5 more, which gives us 50. Now you know what's going to happen now. So let's go ahead and do this. 6 times 5 is going to be the same as 5 times 6, 30. Because we said 6 times 5 has to be the same as 5 times 6. That's our rule today. Let's keep going. 7 times 5 is the same as 5 times 7, 35. 8 times 5 is the same thing as 5 times 8, which is 40. 9 times 5 is the same thing as 5 times 9, which is 45. 10 times 5 is the same thing as 5 times 10, 50. Here we go. And you can see again how they parallel each other. So now we've taken care of our 5s here. Let's go on to our 6s. Alright, we have to start with a special number again. We're going to start with 6s, so we know that 6 times 6 has to equal 6 times 6. So we'll start with that one. 6 times 6 is going to be 36. 6 times 7 will be 6 more than 36, which gives us 42. 6 times 8, 42 and 6 more, gives us 48. 6 times 9, 48 and 6 more, gives us 54. 6 times 10 is the same as 54 and 6 more, which gives us 60. Now let's continue the rest of them, right? 7 times 6 is the same as 6 times 7, 42. Again, our rule, 7 times 6 is equal to 6 times 7. Let's keep going that way. 8 times 6 will be the same as 6 times 8. We know that's 48. 9 times 6 is the same as 6 times 9, 54. And 10 times 6 is the same as 6 times 10, which was 60. Look at the parallels, all nice and even again. Let's move on to our 7s. We have so few left, don't we? We've done such good work. Let's start here again. 7 times 7 gives us a special number, 49. Let's work from that number. 7 times 8 gives us 7 more than 49, which is 56. 7 times 9 gives us 7 more than 56, which is 63. 7 times 10, 7 more than 63 will give us 70. Okay, easy now, isn't it? 8 times 7 is the same as 7 times 8, 56. So that's right here. 9 times 7 is the same thing as 7 times 9, 63. 10 times 7 is the same as 7 times 10, which is 70. So few left. We've done our 7s. Look at how even it is again. Let's put our 7s away. And we'll do our 8s. One special number again. 8 times 8 gives us 64. That's a special number. 8 times 9 is the same as 64 and 8 more, which is 72. 8 times 10 is the same as 72 and 8 more, which gives us 80. What about this one? 9 times 8 is the same as 8 times 9. That's been our rule, hasn't it? 72. Let's say that again. 9 times 8 is the same thing as 8 times 9. Okay. And this last one here, 10 times 8 is the same thing as 8 times 10. And 8 times 10 was 80. Oh, so few left. We've done our 8s. What's that last corner going to look like? All right. 9s. Usually 9s are hard, but look, we have so few of them left. What about 9 times 9? 9 times 9 is 81. All right? And the next two are probably too easy to actually go through, but we'll do them. 9 times 10 is 81, and 9 more makes 90. Right? And we know that 10 times 9 is the same thing as 9 times 10. And we knew that to be 90. So we know 90 goes here. That was really easy, wasn't it? So we've done our 9s. What's that special yellow one at the last corner? What do you think it's going to be? All right, last one here. Last special number is 10 times 10. And you probably already know this one. You could look at the patterns in the table to make sure that it really is 100. Okay. Now, let's reveal them again, and I want to talk about the numbers just a little bit. Let's start with our 1s. See our 1s, how parallel it was on either side. And now our 2s. Our 3s. Our 4s. Our 5s. Our 6s. Our 7s. Our 8s. Our 9s. And then lastly, our 10 here. Now you can see there's a lot of symmetry going on in the times table, and that can help you think about multiplication, because multiplication is commutative. 1 times 3 is the same as 3 times 1. 3 times 2 is the same as equals 2 times 3. 4 times 2 is equal to 2 times 4. There's special numbers here. We're going to talk about those in a moment. 4 times 3 is equal to 3 times 4. 6 times 5 is equal to 5 times 6. 7 times 6 is equal to 6 times 7. And 9 times 8 is equal to 8 times 9. That happens again and again in this table. But there were some special ones we had here. Let's look at these. 3 times 3. Here's another one that's special. 5 times 5. And then I have down here 6 times 6. Let's look at those. The pattern was the number times itself, right? So 1 times 1 gave us 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And you know what the last one is. 10 times 10, 100. Now when we're thinking about commutativity, or multiplication as being commutative, you could see how the numbers are always on either side of this line here. These are special numbers. And you can see 2, 2, 3, 3, 4, 4. You can see here 12, 12, 15, 15, 18, 18. Everything's on either side of this special line. All of these numbers are special in that they are square numbers. And we want to remember them, right? So we have 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. 6 times 6 equals 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 equals 81. And our favorite, 10 times 10 equals 100. So we've done a lot of good work with our times tables today. I hope you learned a lot about multiplication and commutativity and about square numbers, and I hope this will help you. So do come by again sometime. You have a great day.